And let's go the other direction now. Okay, so I can do the inverse Laplace of a product of two functions, and I can translate that into a convolution of two functions. So in our example here, we're doing inverse Laplace of 1 over s squared plus k squared squared. So we just got to think about, well, what would make sense for a product? How could I take that statement and make it look like the product of two functions? And if I happen to define f and g to be the same functions, as each of them are just 1 over s squared plus k squared, then that pretty fits our pattern pretty quick. In which case, our individual functions, f of t and g of t, would also be the same. And that fits our sign pattern. So I think we're missing a k. So I want k. Oh, sorry. Inverse Laplace So in the sign pattern, I need a k up in the numerator, so I'm just going to divide by a k on the outside, which is 1 over k sine of kt. So if we just go back to our definition of convolution, then our our inverse of 1 over s squared plus k squared would be 1 over k squared integral of 0 to t sine of k tau, and then sine of k t minus tau, d tau. Okay, so going forward, we're going to do a little bit of trig review. There's a nice identity that would be lovely to apply at this particular point. So if you want to dust off your trig notes, if you have the product of two trig functions, you can convert that using this identity here. So that's cosine a minus b minus cosine of a plus b. So if I apply that to our lovely little setup here, then I get 1 over 2k squared, the integral of from 0 to t of cosine k 2 tau minus t minus cosine of kt, all d tau. And let me get a little bit more room. So this is a little bit easier to play with. So, 1 over 2k squared. Alright, so let's see. The integral of sine is cosine, and if we take that chain rule idea into account, that's going to give us 2k. So 1 over 2k sine of k of 2 tau minus t. And then same thing, minus tau cosine of kt. But now I want to evaluate at t and 0. And if I clean that all up, it should give me a sine of kt minus kt cosine kt. all over 2k cubed. Alright, so I'll go ahead and put a box on that. Hooray!